Good morning. Thank you all for dropping by. I think this should be very interesting today. We've got some really interesting speakers and some really interesting topics to cover. Without further ado, let's just jump right in here. So the last couple of forums, the last couple of years or so, I've been covering these a whole series of emergent technologies that we believe that will be driving the next generation of manufacturing. So in past forums, I've covered areas like big data and analytics and sort of the beginnings of how machine learning was being applied and things like that. We've looked at the overall in the industrial IoT and connected things and assets. And then last year we looked at some of the new technologies like additive manufacturing, where it's going, how it's really emerging, advanced next generation materials. So we've been looking at a lot of different things. This year, we're going to be looking at the intelligent edge. And more specifically, from the chip makers and the folks that are making the designing and building the processes, we're going to be looking at how AI and more specifically machine learning is really moving out to the device level and how it's going to be enabled by that. So it's going to be AI in the device now. And as I go through my presentation here, I'm going to be basically making the case that it has to be out on the edge because of data. So what do we have going on here? The coming IoT, industrial IoT tsunami of data. It's kind of interesting when you look at this in this perspective. The physical universe and the digital universe have something in common: sheer size, and we're getting to that constant in respect to the volumes of data that we're going to be dealing with. So basically, they require special measurement units, whether you're studying origins of the universe and dark matter, whether you're studying data science. Back around the turn of the century, back around 2000, the consumer data, the data tsunami was predicted. The telecoms in the early 2000s were running around waving their arms saying there's just going to be a huge amount of data created by new devices, by mobility, all these different areas. What we're getting prepared for, what's coming for us right now, that'll be a splash compared to what's coming. Most analysts, and data science folks out there are making some of these predictions. Now we're talking about zettabytes. We've reached the end of the alphabet. I'm not quite sure where we're going to go after that. So they're talking about 8 zettabytes a year between 2000 and 22. That's only 2 years away. We're talking about doubling 16 ZBs by somewhere between the next 2 years after that, and then by 30 up to 35 maybe by the time we get to 2025. And so to put that in perspective, 1 zettabyte of data is equivalent to 1 trillion gigabytes. Intel says that they're forecasting that we'll have 175 zettabytes will be created by 2025. So how much data is that, really? To kind of put this in kind of a perspective. That's the equivalent of 6.5 billion years of high-definition video content. That's longer than the known age of the universe, at least at this point to the physicists. So in essence, it's going to be a big bunch of data we're going to have to deal with here. So how we handle the data is going to be the issue going forward. So most agree today that the IoT and the industrial IoT will generate a staggering amount of data. There's a fairly good consensus on that. The current business discussion revolves around where this data will be processed, either on the cloud or on the edge, and by whom. And that's the battle. Everyone's forming their battle lines in that right now. So the debate, the current debate, or maybe previous to that, some of this is being resolved already as we speak, but the debate has been basically the cloud platform providers maintain that their massively scaled data centers can do the job. And in essence, they probably can if it all had to be done just there and didn't have to go anyplace else. Conversely, the device and chip makers are maintaining that much of the data can be processed at the source with embedded intelligence and purpose-built AI and machine learning in the devices. And this is what we're basically going to talk about here. It's becoming clear that to handle the huge volumes of data, much of the processing will necessarily have to be at the device level. It's moving it around that's going to be the issue. The edge will become more intelligent by necessity because of this. And moving massive amounts of data, of device and sensor data, will be too slow to efficiently process operational data required in a real-time factory production environment. What we are talking about here is operational data. It's the operational edge. I think that should be the key word here. The consensus forming is that embedded intelligence and edge devices powered by these next generation AI processors and inference-based machine learning will drive the future of IoT. So, where's the intelligence? In the cloud or at the edge? Well, in the scheme of things, it's going to be in both. We're going to train in the cloud. We're going to inference, and we're going to process at the edge. So, why on the edge? So when you have a high resource, high power data center with actually using a lot of power too, you've got thousands of classes, and I'm talking about machine learning classes for pattern matching, things like that, and large workloads, and so we can do the training there. When you move that on the edge, then you're moving away from high power and high resource costs. It's extreme low power out there on the processors, in the devices, and it's low cost. And you have less classes and so forth and everything, and I'll get into that in a little more detail. So what's this landscape looking like? So we're kind of looking at three distinct areas right now: the enterprise cloud, the edge computing, and the far edge. So the enterprise cloud is fairly well established in terms of infrastructure, in terms of networking and services and so forth. And we see a lot of infrastructure being offered as a service. And this is where we got the computing and the storage and the networking. This is all kind of traditional stuff that's been in place in most companies. I shouldn't say most, but a lot of companies are operating on this enterprise cloud level. And you have these network platform services obviously being offered by the usual suspects out there, the Googles and the Microsofts and the Amazons and so forth. And all that sits on top of the hardware. Now, as we move to this edge computing environment, this is where it starts to get a little more specialized. So we're talking about more private cloud service. We're moving into advanced controls and more advanced analytics, or actually where analytics really starts to get processed and used, and more networked appliances and so forth, like gateways and firewalls and so forth. And it's platform as service. This is where, as I said, we get into more data management, device data management, which is a big deal actually, analytics, and start to get into the aspects of machine learning and deep learning and neural networking, that kind of stuff. I'll get into that a little bit later. And then as we move to the far edge, this is where we move back to the traditional production systems and controls and automations that all of us old controls engineers know and love. And it hasn't changed a lot there, but this is where all the action's going to be. So it's the IIoT endpoints, it's the intelligent devices, it's the automation and controls. And this is where you have to deal, where the rubber meets the road. It's real time. There's safety issues, there's performance issues. And this is where the inferencing engines will play. and at this and all this, these platforms will be sitting on the hardware. So that's sort of the landscape that we're going to be dealing with. So let's look at the machine learning landscape across the cloud and the edge in a bit more detail. So just to kind of straighten things out a little bit here, because we get so much hype and the terms get thrown around so loosely of artificial intelligence and machine learning and so forth. Let's sort of unpack this a little bit, okay? So machine learning is a subset of AI. It uses mathematical probability and pattern matching, and all Bayesian mathematics, all that kind of stuff. That stuff's been around for decades. There's nothing new here. We just have better computing, more resources. But to learn, and this is where the training algorithms are created. So if you look at the overall discipline of artificial intelligence, it breaks down into these different subsets. You've got machine learning, and then under that you've got deep learning, neural networking, and so forth, and then down into the actual algorithms that are doing the work. And so this learning experience actually mimics human intelligence. This is what learning is all about. It's inferencing. The guys, Marvin Minsky and the boys back in the MIT lab, AI lab back in the 70s figured all this stuff out, and we're building things. So a lot of this stuff is based on basic principles. We just have the technology to derive it now. So machine learning systems are trained to analyze new data and categorize it into classes. This is the classes I referred to earlier, in the context of training data. And this is basically what's known as inference. So the cloud is where this machine learning training takes place. It's performed on big data centers they're remote, and they're power intensive. They're servers with high computing resources, and they use a lot of energy. I don't know if you were to look at the total amount of energy consumed around the world for everything, from transportation, from industry, everything, computing represents somewhere between 2 and 3% of that. Now, that doesn't sound like a lot, but that is a lot of power just from computing when you think about it. Forecasts are that when we really get into machine learning and IoT and all this, and we move into this new era, that power consumption is going to go up to 5 or 6% of total power. When you think about it, it's kind of mind-boggling. So the edge is where the inferencing is performed. So if we were to look at this in a couple of steps, you have the training in a cloud data center, and that can take place over hours and days and weeks, large amounts of labeled data coming in, and they create deep learning models, and they output trained models, and then that goes out to the edge, and these are the endpoints, the intelligent devices, and then that processing is instantaneous. So we're also getting new inputs also from the sensors and devices using this training model. And the cool thing about inferencing is, like learning, just like human learning, additional data that keeps coming in keeps getting processed at the edge through inferencing and learns new things. So it's a continuous process. So the edge devices, once trained, will be able to process very large volumes of data, which is our issue. So what are some of the differentiations and optimizations afforded by processing at the edge? Here, I'm going to be making kind of the case here for it. So this is the biggie right here for controls and automation guys, is latency. If you are processing out there on the edge, and any automation and control guys knows that the closer you get to the device, the less the latency is, and that's critical. It's critical when you get into control systems. So real-time, deterministic, hard real-time applications in production and automation controls cannot rely specifically on remote cloud connectivity, even with 5G. And I'll talk about that in a little bit. Delays in response could have serious performance and safety implications. That's pretty obvious. And going forward, it's not just the factories, but these constraints could apply to, say, automotive performance in current vehicles on the road, and control apps for future generations of autonomous vehicles. It's been forecast that a total Class 5 autonomous vehicle, that's completely autonomous, will require somewhere between 10 and 12 terabytes of data per day. Now, a lot of that processing is going to have to take place in the vehicle for this to work, because just like you can't have latency in control systems, you can't be losing bits for the information coming down to steer the car through the traffic and so forth. Power and cost of data transmission. I was talking about power just a minute ago. Transmitting data it costs. It costs in power to do this, and machine learning is a big user of computing resources. It takes lots to crunch it. And cloud or network performed, what this machine learning does, it adds a bandwidth tax because it's data intensive. And this is a big one too, security and privacy. So the risk to data security are amplified when the data is constantly moved around. Security risks are minimized when the process is performed on the device. Now, that doesn't mean we don't have to have security on the device, because I have to say, having spent a fair amount of time in the embedded world and doing that stuff myself, the embedded industry has been fairly remiss about security over the years, but they're getting it now, and in a big way. But security and privacy has to be designed into the system from the chip to the cloud, essentially. And then the other interesting thing is personalization and customization. As all these devices become more intelligent at the edge, they have the capacity to adapt through inferencing and all these other engines and provide a more contextualized response. So there's architectures emerging. There's architecting these intelligent IoT systems of the future. So new architectures are emerging based on this kind of basic architecture that I went over here. So all these new AI, ML enabled processors are spawning multiple architectures that are redefining the processing of data all through the tiers, all through the multiple tiers of these ecosystems. This will be an integral part. Defining an architecture will be an integral part of successful digital transformation. I always like to say, they always used to say, it's the economy, stupid. It's the architecture, stupid. This is you got to design your architecture. You're not going to have a successful digital transformation. And many companies are in the midst of defining this and implementing this digital transformation, but they haven't yet progressed to designing a tiered architecture that fits their business processes. These architectures and these platforms are being offered by a quickly growing market of edge device suppliers. So they're out there, and you're going to be hearing about them, and they're already coming after the industries and so forth. But not every company will be able to implement an architecture that provides this level of inferencing capability. So what's going on? I mentioned the battle. Well, the AI chip makers are battling to power the intelligent edge. But it's not just the chip makers. Everyone's getting in on the action here, including the cloud platform providers. So you got like Intel with their Nirvana chips, with their processors. They've got one for training, as I was referring to up in the cloud. They've got one for inferencing that'll be in the device. ARM, they're all over this. They've got their Project Trillium, the Helium, the Ethos, and so forth. They've got a PSA security system, and then their Paleon device management system, which is device management will be pretty important in this environment. Qualcomm, they've got a neural networking SDK for their current processors. NVIDIA, they got some of the most powerful, high-speed, just screaming data processing based on their GPU technologies, like the Tesla V100 and so forth, and for deep learning, which it's going to take all this. It's going to take that much processing. And then you've got the cloud platform providers I'm talking about here. Google, they got their TPU, they got their tensor processing, they get the Google Cloud Platform for the AI Edge, DeepMind SDKs. Amazon, they're all over this. They've got their AWS AI, ML, deep learning services. IBM is taking a little bit different tack here. They're not they're more into what I would call the machine intelligence and cognitive reasoning. That's a whole different topic to talk about. It's cognitive reasoning and logic-based inferencing, that kind of stuff. And it's quantum computing. They're going after quantum computing. That's a completely different discussion. But quantum computing is going to if it hits in the next 5 or 10 years, it's going to make this whole issue of Bitcoin and cryptology and encryption and so forth a moot point. But that's another topic altogether, and that's going to change everything. You got Microsoft with their Azure cloud. And what's interesting, these companies, how Microsoft just acquired Graphicore a year or so back, I don't remember how long, their chip maker. You got Apple. They just made an acquisition of Xnord, their processors. So these guys they're all going to start making their own chips and everything for their own platforms. So let me conclude here and take a look at what we would call the 5 waves of computing. Okay, and this is going way back. So first we had the first wave. We had mainframe computing. We had computing centers. We had the venerable IBM 360, 370s, which I hate to admit that I got my teeth on. So I've been kind of belying the fact I've been around a while. The second wave was client server and personal computing. And the first and second waves, they kind of meshed into one another. Then we had our third wave, the internet, the World Wide Web, and then websites proliferated for business and industry. Then the fourth wave, as you can see on the timeline, mobile computing, the cloud, social media. And this is where we're going. We're at the fifth wave. We have the convergence of AI, 5G, and IoT. All 3 of these technologies are reaching, what's interesting is all 3 of these technologies are reaching maturity basically around the same time. They're each impacting the technological advancement of the other. And so the sum is greater than the whole is greater than the sum, and so forth. But this is going to have a very profound effect on industry, business, and cities, infrastructure, and society at large going forward. So that's my spiel. I got a survey out there. There's a link, but we'll try to make this more accessible. So we want to find out where companies are at in terms of some of these levels here of where you're at in using this stuff. And then I've created some intelligent edge specific dimensions of what those levels might be. So that's it. Thank you.